Okay, everybody, welcome to today's second Tuesday of the month seminar. Today, we're going to be talking about color conversion, and it's the part 4 of our demystifying color control. And today's session is the 4th C in our 5 C's of color control. And it's the idea of once you've assessed your instrument capabilities and you've got your printers to be consistent to themselves or your monitors to be consistent to themselves, and then you've characterized them, so you've defined the gamut or the range of color that these devices are capable of producing. Now, how do you get your color from your input source to your different output devices, whether they're displays or printers, and give you the color that you want? Meaning, maybe make your press match your proof, or make your digital press 1 match your digital press 2. It's all about how the color conversion is done. And there's a lot of variables related to the conversion. We're going to cover a number of them in today's session. And like always, I'd like to open it up for questions at any time. So as I'm presenting, if you have a question on what I'm talking about, please feel free to put it in the chat, or even unmute yourself and ask, and we'll cover the question on the fly. So color conversions can happen on either the RIP or a color server. A lot of people use a color server because what it allows them to do is it allows them to set up multiple cues for multiple types of RIPs and standardize the color between these RIPs. So when we're talking about making the color conversion work, it does require workflow software. I was working with a company not too long ago that had some older Canon large format printers, and the RIP and the driver on that Canon did not allow for the ability to do a color conversion, either with process color, meaning images, or even spot colors. So they had to put a color server in front of that Canon printer to get the color to render the way they wanted to render, because the RIP was not capable of it. Now, before you do any conversion, just a little review from the previous 3 weeks is you need to ensure the print process is stable. If your print process isn't stable, anything you do in the conversion isn't necessarily going to work. So that's what the first 3 sessions were about, is helping you understand that your print process is stable, consistent, repeatable, and that once it is, you build an ICC profile for it. And then you choose how you want your color conversions to be performed. Like I said, it can either be on a RIP or a color server. Now, most every RIP and every color server has different variables that can be applied, including rendering intents, black point compensation, the color management method. All these are variables that will affect the color that comes out. And people might say, oh yeah, always use absolute color metric for this process. Time out there. Did you know that the rendering intent, the way the rendering intent reacts, is dependent on the program that actually creates the ICC profile? Which means if I build a profile for my Epson printer, and from the same printed profile target, I build a profile with, let's say, X-Rite I1 profiler and EFI color profiler. Sweet. If I run the same image through the 2 different profiles to the same output device and use the same rendering intent, I will not necessarily get the same result, because every profiling vendor has latitude to adjust how the rendering intents work. The only rendering intent that's standardized is absolute color metric. But even though it's standardized by the ICC, doesn't mean that every developer implements it the same way. So rendering intents is a real wild card. And just by changing the rendering intent from, let's say, perceptual to relative colorimetric, you might go from a 5 E factor result, which is maybe unacceptable to you, to a 2.5 E factor result, just due to the change of the rendering intent. So rendering intents can't be underestimated. The next thing to define in your conversion process is defining the input profile, meaning when you're doing a color conversion, I liken it to directions. Let's say you're going to invite me to your house tonight for a barbecue. First thing you're going to ask me is, I'm going to ask you, how do I get there? Because I need to get directions to your house. I don't know where your house is. What you're going to ask me is, where are you coming from? And that's what the input profile defines, is where is the file coming from? Meaning, what gamut is the file in to begin with? And then we convert it to the destination to get it to where you want it to be. If, in my direction analogy, I say, how do I get there? You say, where am I coming from? And if I say, I don't know, you're not going to get me to your house. And this is the same concept that has to be applied to images, that if you get images or pages, PDF pages, and you don't know what color space these files are in, your printer could be printing perfectly to Grackle. But because the file isn't in the Grackle color space, it can look terrible. The gray could be green, the highlights are washed out. So this is a really key point. Even though your printer might be totally dialed into Grackle as best as it can be, if the physical file itself is not in the Grackle color space, you could get a really bad output. So it's imperative that you ensure that all the files you get from your customers are in the right color space. And when I say right depends on what your goals are in your process. If you're trying to make all your devices match Grackle, then all your files should be in a Grackle color space. And if you think about it, how does a PDF get made? It gets made from, let's say, a program like InDesign, and Bobby might have worked on pages 1 through 3, and Sue worked on pages 4 through 6, and Sue's color space was set for, let's say, sheet-fed coded, and Bobby's was set for US Web Coded Swap, and John's was set for. You could easily have PDFs with multiple images in multiple color spaces, which when I run through a perfectly color managed workflow for the printer, I'll get varying color results based on the images on the different pages based on their input color space, which is a really big problem in the industry. So ideally, your company should have a color server that can normalize all the elements within your PDF, including the PDF itself, into your desired color space. So that as part of the pre-flight process, when you get the file in from the customer, you might have a queue to normalize everything into a Grackle color space. You might have another queue to normalize everything into, let's say, a print-wide large gamut color space. In this way, it gets all the sub-elements within that PDF into the same color space. It normalizes the color so that then when you do print it on your color managed printing device, it's printing as expected. So defining the source space is key. And then you need to define the output space or the destination space, because every printer, even same make and model, one serial number apart, image color differently. So depending upon your quality requirements and the type of printers you're using, you typically do want different ICC profiles for each printer and each substrate. Because again, paper's the 5th color and 4-color printing. You want to be able to accommodate that with the profile. Now, we showed you the last couple sessions how you can actually streamline your profiles. So even though you might print on 30 different coded paper stocks, doesn't mean you want to try to manage 30 profiles. With ChromaChecker, you can quantify based on your expectations of a color match, how many profiles you need to properly represent those 30 different paper stocks. You might only need 2 profiles, and 10 might be on one and 20 on the other, and that simplifies your workflow for doing your conversion. But you do need to define this, and that's part of our characterization session that we covered last time. We're getting, and but by the way, these are all recorded online that you can go back to and revisit if you missed them. But in this way, we need to now define the destination color space so that we can convert our input color to our output color. And if you deal with brand colors, like spot type colors, ideally these colors should be in a named color format, like Coke Red. And you don't want to try to manage brand colors in a CMYK or RGB color space. It just will not give you the type of quality you're requiring. So we've got a whole session today talking about how to do a named color lookup table, or a LUT, in order to get your brand colors to image on your printers the way you want them. And again, just to back up, it's all about this analogy of you've got to know where the file is coming from in order to get it to the output device in the print condition you want it on, so it gives you the result you need. And to show this with displays, first off, a lot of people don't know that with ChromaChecker, we have a tool called Display Inspector. This allows you to easily create display profiles for soft proofing. And if you've ever tried to use soft proofing software, you know there's a lot of variables, and unless every user uses the same variable, you'll get inconsistencies across the displays. Well, what ChromaChecker's done, being a centralized cloud system, is we've put all the parameters for how you want your displays to render on the cloud, and then we pull out to the user, and all the user does is put the instrument on the display, and then the cloud drives all the standards so that all the users using the same queue within Display Inspector, they use the same parameters. So it leaves nothing up to the operator, so you have no inconsistency on the result. And having a display profile is important, because if I have an original color and I send it to Bobby, it's the same RGB values, but it'll render a different color on the display, even though it's the same RGB values. It's like TVs in a Best Buy. You look at the same make model TV, each of these render different colors based on the same RGB definition. So we need to have a profile for each of these displays, and then we can render the spot color through these different profiles so we get the same result on every display using different RGB numbers. That's the key. Think of it, again, with my direction analogy, it's also like languages. The first display speaks French, the second display speaks Swahili, the third one speaks, we'll say, Spanish, and the original is in German. And I've got to be able to convert from German to Spanish and Swahili and so forth, so I honor the intent of the color, which means the RGB values will change in order to maintain that shared color appearance. And it's same thing with printing. If we take the same color with a definitive CMYK value, output it on 3 different printing devices using the same CMYK value, I don't get the same color. I get very different results. And this is why we need to be able to convert from one color language to another color language to honor the intent of the original. Color management is all about honoring the original. Here's a same scenario, but with an image. So I have an image, I run it to my 2 different output devices, and without color management, I get 2 completely different results from one another, and they're totally different from the original. So let's talk about strategies for setting up your printers now, because you need to ask yourself, is the goal to make all my printers match one another? So do I want to match my ViewTech with my Xerox? The ViewTech typically has a larger gamut than the Xerox. So if I'm going to match the two, I'm going to have to dumb down the color on the ViewTech to match the Xerox, because color management does not make a device produce more color than it's capable of. We can only manage what the device is capable of rendering. And this is obviously contingent on the ink settings and the paper and other variables like that. Number of passes, all this plays into the gamut of the printer. Now, I might have a situation where I have a lot of customers that use my ViewTech that will never use my Xerox. So, and more color or more vivid color is always more pleasing for the majority of people. So if I can maximize the color on my ViewTech, why not set up one queue to do that? And so for all my customers that are only going to use my ViewTech, they get maximum color gamut. And then for the customers that need to print on both the ViewTech and the Xerox, I can set a separate queue up and have the ViewTech dumbed down to the Xerox so that they match one another. So in this way, you need to think about your strategies for how you want to manage your color. And we're going to go through how you can optimize these strategies to deliver on your goals. So here's the strategic issues: maximize gamut or match color. Now, like I said, most everybody likes a higher degree of saturation in their colors. And for this, it's a great thing. And so we want to do that. We want to maximize the color if we can. And ideally, we want to keep our G7 gray and G7 tonality. So if someone is looking at a print from another printer with a smaller gamut, as long as that's G7 as well, they'll at least have a shared visual appearance. They won't match. They will have a shared visual appearance. So they'll have the same gray balance and the same tonality, but one will be more vivid blues and reds and so forth. The other one will be a little more subtle. So that's what we call a shared visual appearance. So when we help companies set up their printers to have a maximum gamut, we ensure that it's a maximum gamut, but it's using essentially a G7 profile as the source profile to ensure this tonality and gray consistency. When we're dealing with a color match between printers, that's when we're dealing with, again, another queue, and we're dumbing one printer down or multiple printers down to match the lowest common denominator, because again, we can't make a printer print more color than it's capable of. And most companies I work with have a mixed environment. So they'll have multiple queues for each printer. One queue set to maximize gamut and one queue set to simulate, let's say, grackle. So depending upon the job coming through the workflow, it'll be spec'd as either max gamut or simulate grackle, and it just goes through the right queue and you get the desired results. Now, when I talk about a shared color appearance, this is a gamut sampler that we manufacture to help educate people about different gamut sizes. There's an ISO standard 15338, and there's 7 different defined gamuts called CRPC1 through CRPC7. CRPC1 is the smallest gamut, and it's based on newsprint. And if you look over on the left side of the screen, the very left is an RGB image, because we include this in because people are always asking, well, I'm expecting the RGB on my monitor. How come I can't get the RGB on my monitor on my printer? Well, you get this printed kit, and then it talks you through and it shows you real life examples of, okay, here's what it looks like in RGB. Here's what it looks like in CRPC1, which is the lowest quality paper, the cheapest paper. Because what's #1 cost in printing? Paper. So typically CRPC1 is the worst printing or the smallest gamut printing. And then as you go up, CRPC1, 2, and 3 are actually based on uncoated paper stocks. We're just beta testing a CRPC 3.5, where I don't know that that'll be the final name, but it's for printing on uncoated paper with UV inks, which give you a larger gamut than conventional ink. So it's about halfway between CRPC 3 and CRPC 4. If you want more information on that, email me, I can get it to you. And then CRPC4 is like a low-cost coated paper stock. 5, 6, and 7 are more higher cost coated paper stocks. So in this way, based on your budget and the type of paper you can afford, you can get an idea of what the image is going to look like. And so when we're dealing with color conversion, we need to figure out, what's my goal? Is a shared visual appearance good enough, or do I need a color match? And what do I match to? Do I match to CRPC 5? Because I'm only dealing with a number 5 paper stock, or can I match to a higher quality paper stock, because number 1, my printer is actually capable of doing it, and number 2, I'm going to pay the money to have that higher quality paper to actually use in my production. So when we talk about the details of a conversion for PDFs, again, in this scenario, we're going to say the goal is to maximize the gamut. And to maximize the gamut, we need to first define what is the input profile or source of the image. And for this, you want to define a large gamut CMYK profile. There's a number of these on the market today. I'll talk about a couple of them today specifically, but by taking your image, and you can all try this at home. Take an image, bring it into Photoshop. If it's CMYK, your Photoshop's defaults hopefully are on Grackle or Swap, something along those lines. But if you go into the edit and assign profile and assign a large gamut CMYK profile, like either the ChromaChecker wide gamut profile, which is available free from our website, or the Ideal Alliance print wide profile, you will see that your image will pop in color, meaning everything, all the vivid colors will get more saturated. Your grays will still stay gray. Your tonality will still stay in line, but the colors of the flowers and the fruit and the target will all pop dramatically. So what you're doing is you're saying, hey, this large gamut file is what I want to reproduce on my output device. So in this way, once we define our input profile to be, let's say, ChromaChecker wide gamut, we then do a color conversion using either our color server or our RIP to take advantage of the full gamut of the output device. So we go from our ChromaChecker wide gamut into my ViewTech color space, and now I take full advantage of the color that the ViewTech is capable of, but I keep the hue angles aligned. So the blue of Grackle is still blue in the ViewTech. It doesn't go purple. The reds don't go orange. Some of you might remember years ago, some people on Ideal Alliance promoted this thing called G7 Extreme. G7 Extreme was a nightmare because it did not hold the hue angles for your red, green, blue overprints in line with Grackle. So you could do G7 Extreme and your red tomatoes would be orange and your blue sky would be purple, and it just didn't work. But using this methodology of using an ICC profile as the source, a large CMYK ICC profile as the source, and then your output profile where you've got the ink limited to the maximum amount on the best paper, you can get phenomenal color results on your printers. And so I get the color results on both printers, and they might not match one another, but they will have a shared visual appearance with one another. Now, here's a screenshot from ChromaChecker Profile Inspector, and on the left, we're looking at print wide versus Grackle. So print wide is the green gamut. You can see it's very large. The black is the Grackle gamut. And then on the right, the black is the ChromaChecker wide gamut profile, and the green is the Grackle. So print wide and ChromaChecker wide gamut are both large gamuts. They both work well. You should experiment to see which one you like better in terms of how it renders colors. And I've got some samples here. So this is a famous old image, and the one on the image on the left is in Grackle color space. The image on the right is in a wide gamut CMYK profile. And notice the red on her sweater, notice the green in her sweater, the pink of her hat, the blue of her sweater. See how those colors are just much more vibrant than they are on the left. Yet it's still the same hue angle for the blue and the green. The hue angle's not switching. And look at the flesh tones. The flesh tones are still really good. So you get the best of both worlds. You get the maximized gamut and you get G7 tonality. Here's another example from the movie Dory. The image on the left is in US web coded swap, and you see it's kind of purplish and kind of muted. But when I go into Photoshop and I take this image and I assign the profile for print wide, you get the result on the right. So it's much more vivid. It's still kind of purple. Now I did the same thing with the ChromaChecker wide gamut. Notice how ChromaChecker wide gamut tends to make it more blue. There's still purple in there. There's a purple bias. Well, look at the water. The water is really blue on the one on the right, even more so than the one on the left. And if I just back up for a second to show you again print wide, notice it's blue, but it's more purple. And now I'm going back to ChromaChecker wide gamut, and you can see it's more blue. So there's not a right answer in terms of which large gamut ICC profile is best. Experiment, see which one you like, see which one renders your images the way you want them rendered, and then go ahead and use that profile in your workflow. So the process in a maximized color gamut workflow is you assign the large gamut profile, and then you apply the color conversion, again, to take it from, let's say, German to Spanish, directly out to your output device's gamut, taking full advantage of what the output device is capable of doing. And in this way, like I said earlier, they don't match, but they will have a shared appearance as long as you use a G7 based large gamut profile, which both ChromaChecker wide gamut and print wide are. So you'll have the same tonality and the same gray balance between them. Now, the actual steps to do this, number one, again, you need the file in the right large gamut color space. Number two, you want to assign it into this large gamut color space. You don't want to convert it. So you assign it, which actually doesn't change the pixels or the colors in the image. It's reassigning that this combination of CMYK value instead of this LAB value is this more saturated LAB value. And essentially it gives new definitions for what the CMYK should look like, because again, we're trying to reproduce the original, so we need to know what it should look like in order to reproduce it. And this type of thing is easily done in a color server. I've got a screenshot here of All-in Color Hub, where you have an input section to set your input profiles for your RGB, LED, gray, and CMYK color spaces. And then you have an output tab, which allows you to set the output settings. And when you're dealing with large gamut, typically you want black point compensation on, because this overrides the black point in the original file and takes advantage of whatever black point your output device is capable of, which when you're doing maximum gamut, you want to do that. You don't want to do that when you're doing a match, but when you're maximizing gamut, you definitely want your black point compensation on. And the embedded profile in this scenario, you actually want off, because the file might have an embedded profile of Grackle, but if you leave it in Grackle, you won't get the extra gamut that print wide has. So by turning embedded profiles off, you're forcing everything into this CMYK large gamut, so you can be assured to get the large gamut out of your print device. And again, with rendering intents, you want to experiment with that. So in the printer, to configure the printer to be ICC profiled, you want to make sure it's calibrated in a stable condition, linearized and ink limited to give you maximum chroma. You want to look at your hue angles on the chroma and make sure they don't overly hook or hook down and in, meaning they're losing saturation as you add more ink to it. You want to keep that color as pure as possible. Once it's pure, run your profile target out on that printing device, create your ICC profile, and now you've defined the large gamut profile of how that printer prints. It doesn't matter so much that that printer is not G7 compliant, because if our input profile is G7 compliant, when we run it through the conversion, the output device will then become G7 compliant. In the workflow, you'll set the input source profile as your large format profile. You'll put the output profile in the output device and then experiment with the rendering intents like we discussed. Black point compensation typically turned on, and then print. And I've been in printers where when they printed the results, they're like, who printed this? Who printed this file? The owner, when we take the prints from the print shop back to the owner and we say, hey, look what we've done. And they say, what printer did this come off of? And you say, yours. And they're like, how did that happen? I've never seen color that good out of my printer. And you say it's all in the magic in the configuration. And that's what intelligence helps you do is create better color. And I've done this also with ECG. So when we're dealing with ECG, so many people say, oh, to make ECG work, you got to start with RGB images. No, you don't. You can start with a large gamut CMYK profile, and it drives data into the extra channels, the orange, green, violet channels that wouldn't have normally been driven into those channels. So when you print, you get advantage of the ECG ink set of the printer. And again, you'll have color that you've never seen before. It'll look fantastic. And owners will be like, our printer did this? I didn't know we could do that. You'll be a hero in your shop. Okay, so in this way, just a refresh of what we talked about, large gamut, do the profile conversions, and you'll get a shared visual appearance on the printer. Now, strategy number 2 is when you want to match your color from one to the other. So the first thing is you define what you want to match to. So we'll say Grackle. Now, if you want to match to Grackle, you need to ensure that your printer is capable of producing a gamut bigger than Grackle. We've had so many customers, we've got a bunch of brand companies like Lab, who have a specification that for their high quality work, you have to hit Grackle within a 4.5 EFAC. Well, companies will choose printers with smaller gamuts than what Grackle is capable of and try to make it match Grackle, and it can't do it because the printer doesn't have sufficient range of color to simulate Grackle. And then they call the printer manufacturer and say, hey, your printer's not working. It's like, no, the printer's working fine. You're just using it in the wrong application. That you never should have bought this printer if you were going to try to simulate Grackle. You should have known ahead of time that this printer is not capable of doing it. So when you're trying to simulate Grackle, now the input profile becomes the Grackle or whatever the source is, and the output profile is still the ViewTech. But now with the rendering intent, you'll use either relative color metric or absolute color metric, or potentially some workflows have a hybrid, which is like absolute color metric, but it doesn't match the white point, so you don't get a scum dot. So in this way, you could still match the color without matching the white point so that the color is clean and fresh and doesn't look like there's a scum dot on the print device. And then the same thing with the iGen. And now you've got your iGen matching your ViewTech. So this is the second scenario of matching color. And again, you need to make sure the output gamut is bigger than the original, and you will get color matches. So the steps in this for matching gamut, again, need to understand that the original file is in the right color space. So we'll say Grackle. Then you assign, don't convert, into that original color space. Easily done with a color server with black point on, and ideally embedded on as well when you're doing a match. So the embedded profile gets turned on when you're doing a color match, because you're trying to match to the author's intent, which is the original. And that's the point of an ICC profile, is it define an embedded ICC profile in an image or a PDF is defining the color space that that client wants that image or that file to be in. So how do you configure the printer to be profiled? Again, you make sure the printer is stable, you calibrate, you linearize, and you ink limit to values just bigger than your target gamut, like Grackle. You don't want to overdo it. Then you create a profile, and then in the workflow, you apply your reference profile of your source of reference that you want to match. You apply the destination profile of the given printer and substrate that you're printing to. And then this is where you'll experiment with the rendering intents. So oftentimes I'll have someone print and they'll be like, my E factor of my iGen to my Grackle proof is 4.5. And it's like, okay, it's not terrible, but let's see if we can do better. Just change the rendering intent from relative to maybe a hybrid rendering intent, which is essentially absolute colorimetric without mapping the paper white. And they'll see that 4.5 E factor go down to a 3.5. And they're like, oh my goodness, I thought I did something wrong, but the profile and the configuration was all set up right. This one little tweak on the rendering intent helped improve the color match and the E factor values that they were getting. So the result will be the printer will be G7 compliant with good hue angles. Now, how will it look in something like ChromaChecker? So how to check conformance? Because if you can imagine, okay, I've got a printer set up to match print wide, and the same printer set up to match Grackle, and I'm also doing the same printer on lamination, and I'm also doing uncoated. How do I keep all this straight? This is, my head's blowing up. And this is where a color conformance tool like ChromaChecker comes in, where I've got my color press as the digital press, and then I have multiple tracks. And the tracks define the different print conditions. So I've got a track for coated, which is simulating Grackle. I've got a track for uncoated, which in this case is simulating a custom CRPC called a CRPC 5. And then I've got a track called coated full gamut. So this cue and this track assesses whether or not the printer is printing to the full range of color that the printer is capable of hitting. And then I also have a couple lamination cues, one for pre-lamination, so that if I'm going to print a job and it's going to be laminated, I can't tell you how much money is lost because the job is printed wrong, but because it wasn't checked, it was then laminated. So now you have the extra cost of the print and the lamination, and it's still wrong, and you didn't even know it. Whereas if you check the pre-lamination first and you see it's wrong to begin with, don't even take it through the lamination step. Fix the printer, get the pre-lamination where it needs to be, then laminate it and get it passing. And ideally, you could do things like make it so that the pre-lamination is not G7 correct, but after the lamination is applied, it then becomes G7 compliant. And we've actually got how-tos and how to do this within ChromaChecker, so you can learn how to set this up in your workflow. Very powerful capability. So now let's move into brand colors. Okay, so we've focused the entire presentation so far on converting images and pages to give you either max gamut or a color match. Now we're going to start talking about brand colors. So you've got a brand color, let's say this pinkish color, and you need it to match on your printer. And as we've already talked about, you're not going to do it with CMYK. If you try to render this in CMYK and render the same CMYK on 3 different printers, even same make and model, 1 serial number apart, they will all be different. And almost no brand company will accept that. So what you want to do in a brand color conversion is ensure that the brand has named the colors as the brand colors. And ideally, when I say name, I don't mean a Pantone name. And I'll tell you why in a second. I mean, we encourage all the brands we work with to make custom names for their brand colors. So Best Buy blue, Best Buy yellow, Nabisco red. Don't use Pantone 185. You know why? If you use Pantone 185 and I'll put it on a GMG rip, GMG defaults to an M2 lookup table for the Pantone library. Well, okay, so it's going to use a certain definition of what Pantone 185 looks like in M2, which is different than an EFI rip that's using the Pantone lookup table in M1, because the M1 library and the M2 library are different, and in some cases 2 delta E different. You could have, again, a proofer set up GMG perfect, a proofer set up with EFI perfect, the workflow configured perfectly, the name colors looking up the tables perfectly. And because the two vendors are using two different libraries, two different Pantone libraries, one for M2 condition and one for M1 condition, they will not match. And therefore, if you changed it to Nabisco red, now Nabisco red, you load that lookup table on the GMG, you load that lookup table on the EFI, it's the same lookup table, you don't have this disconnection of a lookup table, and you get the colors the way you want. So make brand colors, name colors, and make them specific. Get rid of the PMS naming convention. Make them a specific name so you don't get this lookup table mismatch on the prints. And then the workflow, i.e. whichever RIP or work color server you're using, looks at the file and says, oh, Nabisco red. Oh, okay, on this printer, it's this CMYK. On that printer, it's this CMYK. On this printer, it's this CMYK. It knows automatically how to optimize the build based on the print profile that you're outputting to. And with ChromaChecker, we have the ability to take these named brand colors, apply a profile, like in this case, Grackle. I took the Best Buy library, applied it to Grackle, and it automatically stack ranks all the Best Buy colors, showing you what's in gamut and what's out of gamut and what the CMYK values are for these colors for this print process. If I were to change in ChromaChecker Grackle to my ViewTech, the CMYK values for Best Buy Blue are going to be changed dramatically, but the end result will be very similar. Now, in this case, I'm actually showing that there's 3-4 colors that are more than 2 delta E out of gamut. So if you want to match Best Buy Blue on Grackle, you've got to be able to change your tolerance to about a 3.8 delta E, because this color is not within the gamut of what Grackle is designed to reproduce. So you might either redesign that Best Buy Blue so it's within the Grackle gamut, or you tell them you have to run Best Buy Blue as a spot color so you don't get the 3.8 delta E out of gamut. And by out of gamut, what we mean is, here's a 3-dimensional representation of Grackle, and then I drop the Best Buy colors in here, and you can see those 3 Best Buy colors are outside the gamut of the print process. And with ChromaChecker, we're actually simulating, okay, it's 3.8 out of gamut, but what's that going to look like? So that you get a better idea of, okay, is it really getting dull and washed out, or is it semi-dull and washed out? So you can actually show this to people and say, is this acceptable? Because so many brand companies will say, oh, I got to have a 2. It's like, that's an education issue. In many cases, getting a 2 delta E match on a printer is very difficult, and it's possible, but you need to expect to spend a lot of money to make that happen. And as a brand company, you need to expect to pay a lot of money to make this happen. And so in this way, sometimes a 4 delta E is visually acceptable, and you need to get buy off on this. And we have a new mechanism to set brand tolerances for colors that we'll talk about on another session. It's called a snowflake tolerancing, which helps alleviate some of the limitations of delta E, but we'll save that for another day. So in the brand color steps, number 1, you want to make sure your brand colors are set up as named colors. And then you need some sort of way to automate these named colors, so that we're working with a customer right now who has their brand color is really important, but all their brand logos are defined in CMYK. It's like trying to manage that's going to be a nightmare. It's not going to work well, because trying to manage brand colors in CMYK, even though you get the process images right, to get the tighter tolerances that brand customers require for brand, you really need to turn them into named colors. And some color servers help automate that process. Next, you need to ensure the brand colors are in the gamut of the printer you're trying to hit. I've seen so many times where people will try to output a brand color and they can't hit it, and they do 10 iterations before they realize it's out of the gamut of the printer. Can't do it. So you just wasted all that time and energy. Next, you need to make sure your workflow can accommodate the named color list. A lot of RIPs have a 28 color named color limitation. So I did a job a couple of years ago where the company had a 900 patch chip book, a chip book with 900 different colors. And the rips that we were working with, and real well-known rips, couldn't accommodate more than 28 named colors. So we actually went to a color server, and we were able to handle an unlimited number of named colors to do the automatic substitution and export the name color list into the RIP or the server that we could then match on press. So in this way, when the brand color is looked up, so that Nabisco red is looked up, it knows it's a different CMYK value on the ViewTech than it is on the Mamaki, than it is on the Xerox, but the end result is they all match one another. So in summary, planning and execution is critical for success when doing your color conversions. You need to determine which printers you want to render in full gamut versus simulated mode. You want to ensure the customer files are provided in the right gamut, and if they're not, you want to make sure that you have a mechanism to normalize them into the right gamut. You want to optimize your ICC profile procedures based on your methodology, and you want to configure your workflows for optimum conversions. So one workflow for large gamut, one workflow for simulate Grackle, one workflow for simulate Grackle uncoded. And then by all means, verify results, which is all about color conformance, which is our next month's topic, to ensure that that printer is printing the way you're expecting it to print for the given print conditions. So you can imagine as you start having multiple print conditions for one printer to represent different gamuts and different types of processes, you need to verify these different print processes. And it can get a little confusing, but this is where automation comes in and things like barcodes, where you can barcode each print condition so the operator doesn't have to remember, oh, this came off of ViewTech 1 on a styrene, and this came off ViewTech 2 on a cardstock, and oh my God, which cue do I choose? And we'll show next month how we can automate all this, making it really easy to manage and operate. So hope you join us next month. To learn more, please follow us on LinkedIn. Here's the link here. Also, if you haven't done so already, please download our ChromaChecker trial software and play with it and see how it works for checking your color conformance. Next, we have we're officially announcing our color quality conference for next year. We had overwhelming great feedback from this past year's conference. We did a terrible job of marketing it. We only had about 45 people there. We're expecting at least double this year, maybe more. It's January 30th, 31st, and 1st in the Tampa area again, Newport Richey. We've outgrown our facility, so we have a nicer facility for the conference. We'll have multiple tracks. And then, of course, a reminder for next month's session on conformance, the 5th C on July 11th. So at this point, Beth, do you have any questions for me?
Yes, I have two. Do you want them together or individual?
No, do one at a time, please.
Okay, first one is, do all conversion programs convert color the same way?
Okay, great question. Absolutely not. As I mentioned in the session, you could have the exact same data set, meaning printed profile target, measure it with the exact same instrument, and build two different profiles from two different vendors, and start with the same reference profile like Grackle, and output through using the same rendering intent, and you will not get the same result. And the couple big reasons why are the CMM, the color management method, which is built into the color conversion process of each RIP, and then also the rendering intents. And just a quick background, I was part of the ICC when it was formed and standardized back in '94. And we had to make concessions to some companies that we wanted to join the ICC. And one of the concessions was we had to leave the CMM and the rendering intents open architecture, meaning let the vendors apply their special sauce in those locations, to not standardize that, which frankly I fought against, but we never would have gotten some companies to join the ICC if we hadn't opened that up. So it was a catch-22. But because of this decision made 20 years ago, we have to deal with inconsistencies when running color conversions between, let's say, a Caldera rip and a GMG rip and an EFI rip. And this is why putting a color server in front of each of those, so you ink limit and calibrate within GMG, EFI, and Caldera, but you do all the color conversion in front of it using a color server. Now you can standardize how that color conversion takes place. I hope that answered the question. Pipe up or put notes in the feedback. If not, what's the other question, Beth?
Okay, the next one I had is, if I have 3 different rips, how do I bring the conversions more in line with one another?
Oh, wow. I answered my own question with the first answer. So it's by not using the actual conversion engine in each rip, but to standardize on a color server, like an all-in color hub that's put in front of the rips. So you take that variable of the CMM and the variable of the rendering intent out of the equation. And I've got a lot of large format shops. If someone wants references, I have references that I can point to where they have, oh, I got one shop that's got at least 60 digital printers and all the color conversions. They're all normalized in Color Hub. And then the final color conversion is all done in Color Hub as well. And a benefit of Color Hub is it does have an ink savings module. So you can save a tremendous amount of ink in doing these color conversions, oftentimes way more than what the rip itself is capable of doing. So you actually get a huge benefit in terms of ink savings by using this process as well.
Okay, there's another question.
Great.
The first one is, what is the difference between assigning and converting a file to gamut target?
Okay, great question. For this, I'm going to open up Photoshop because we really have to see it to really understand it. And what I'm going to do is I'm going to open up an image. Oh boy. Okay, we'll open up this image, and we'll open up in RGB. Okay, so here's my image in RGB. Now, just for expediency, I'm going to quickly convert this into Grackle CMYK. Okay, and we'll start with Grackle CMYK. So right now,
we're looking at the image, Dave.
Oh, I'm not sharing my screen. I did all this without you guys seeing it. So let me go back to Zoom, share my screen again. Thank you, Beth. And here we are in Photoshop. Okay, so all I did was I went into edit, and I'm going into my assign profile. And when I assign the profile, I'm going to assign another profile. We're going to assign ChromaChecker wide gamut. So here's my ChromaChecker wide gamut. And when I assign it, look at the Coke truck. Now this middle image being grays, there's no saturated colors in here, so you're really not seeing much of a change. But you see the Coke red? The Coke truck is changing to be more vivid because ChromaChecker wide gamut has that in it. But the CMYK values are staying the same. If you see if I go to my info here, you see the CMYK before and after have not changed at all. Because what we're doing is we're just reassigning what that CMYK build means. This was not a good image to show a wide gamut sample because there's not that many out of gamut colors here. But let's go to print wide now. So here's print wide. And again, you see a difference in the Coke red, but not really in the other places, which is good. It's protecting the flesh tones. It's protecting the tonality. That's really what you want. So that's assigning. So now I haven't changed the color of the file at all, meaning I haven't changed the CMYK values. I've changed the CMYK definition. So you can assign different profiles to an image 100 times and it doesn't degrade the image at all. Now, once I do a conversion, so this is when I'm converting, and this was what you want your color server or your RIP to do out to your printer. Now I'm going to convert this to my Epson, okay? And now if I move this off the screen and I say the preview, now if the conversion's doing perfect, you shouldn't see any difference between the preview and the not preview. But what it's doing is it's going to greatly change the pixel values. The CMYK values are going to completely change because we're rendering these colors into the Epson color space so that it renders properly on the Epson. And you'll see here also the effect of different rendering intents. So if I change perceptual, you probably saw a darker halo come over the top. If I go to absolute colorimetric, you see all that kind of white fog, that tint came down on it. So this is where you need to experiment with the rendering intents to make sure you get the right one to do your process. But if I were to convert now, the CMYK values of this Coke red would be totally different than what they were to begin with, because now I've optimized this file specifically for this print device called Epson PJ. Hope that was helpful. We actually have a white paper on this with a little how-to in terms of assigning and converting that we'll be happy to share with you. So just either email me at david@chromachecker.com or Beth, and we'll get this out to you. Was there another question, Beth?
Yeah, how ChromaChecker can identify if a color out of gamut, is it by the E factor value and then in parentheses above threshold, or visual simulation?
Okay, so I think this question is related to spot colors. So what I'm going to do is go into my ChromaChecker. And I'm going to go into my assets for my colors. And we'll just go to the Pantone library. Okay. And I'm going to go into my virtual spot. So within ChromaChecker, we have a tool called Virtual Spot. And what Virtual Spot allows us to do is choose an ICC profile. So you see I've got some ICC profiles built with a spherical spectro on foil. I've got profiles built for different types of print processes. So if we go to a HP Indigo, and I say I want M1, and I say show, ChromaChecker is going to render these 1,846 colors through the HP Indigo profile and show me which colors are in gamut and which colors are out of gamut. So it's saying 62% of these colors are within a 2 delta E, and these are the worst offenders. So these top colors are the highest delta E's at 15, 11, 10. And then you see here, as I zoom in, you can see that we're simulating that reflex blue is not nearly reflex blue. You know, you're hoping for this really bright blue, you're going to get this really dull purple on the indigo. So this is how ChromaChecker is going about simulating it. And then we're also giving you the optimum CMYK values for the indigo to get to a 14 delta E. I'm sorry, that's the best we can do. And then you can see that in a lookup table for your Wasatch RIP, your Onyx RIP, your Zycon RIP, your EFI RIP, your Caldera RIP, your HP RIP, any of these RIPs, we can save this lookup table into, so that then this populates into the RIP as long as it doesn't have the 28 color limitation. And then as the jobs go through the RIP, it says, oh, I'm printing on my indigo on coated paper. I'm going to use this CMYK value to hit this Pantone color, and boom, here it is. And then ChromaChecker can track the LUT and can tell you whether or not the printer is actually hitting that color. And ChromaChecker gives you the ability to iterate the LUT, so it'll adjust the CMYK values. This often happens with gray, not so much in vivid colors, but on gray values. If you built that profile 2 months ago, that printer is probably not printing the same gray as it was 2 months ago today. So ChromaChecker will actually iterate the CMYK build of the gray part of the build to better match the color automatically. So you don't have to have someone going, well, I think it needs 2% more magenta and 6% more cyan. No, that's old school, old day. You don't have to do that anymore. So did this help answer the question in terms of how does ChromaChecker predict what the colors are going to be and how it maps?
I don't have it.
So,
Yes, it does.
all right.
But
Well,
I have another question.
okay, we'll take another one. We're running a little over, but that's okay.
Can we have access to the ChromaChecker wide gamut to download?
Absolutely. If you already have ChromaChecker, all you have to do is go into your tools, ICC profile, go into the public library, and under ChromaChecker, it's called ChromaChecker wide gamut. Just click the checkbox here, import selected, and it will import into your library, which you can then download. So it's already in my library, so I'm going to go back here. So as I scroll down and I go to my ChromaChecker wide gamut, all I have to do is click on it, and I can download it, and it's just downloaded to my computer. And this is how you can compare like ChromaChecker wide gamut with the print wide from ID Alliance, and say compare. Now we're kind of geeking out here, sorry, but you can see the gamut size, you can see the M conditions, you can see the color differences, you can see the gamut differences. So really interesting to see the difference. Hence, they both give you different results. It's more a matter of taste, which one you like. They're both G7 compliant, so it's all a good thing.
Okay, I'm not seeing more questions.
All right, well, hey, we'll wrap it up for this week, or this month, I mean. I hope everyone enjoyed it. And again, the recording will be available by tomorrow. And if you have any feedback or questions, comments, please feel free to reach out to me directly. And I hope we see you next month at the 5th C color conversion. Thanks, everyone.